Okay, there were 3 questions on the review sheet that I would like to show you maybe how to do a short way and then how to show you maybe a long way. And this would maybe depend on how much time I had. Now there were questions 12, 13, and 14. So for question 12, it says I have 16 grams of methane. And I think it helps for us to know that methane is 16 grams per mole. So that means I'm given 1 mole of methane. And it says I have 32 grams of oxygen. Now oxygen again is 32 grams per mole, so I have 1 mole of oxygen here. Now it looks to me in the reaction that we should have a 1-to-2 ratio, but I only have a 1-to-1 ratio. The thing that's limiting there is the oxygen. I don't have enough of that. So that means that when this reaction is over, that will be all gone. I will have 0 moles/0 grams of that left over. So if I have half as much being produced of these products, I'm only going to make 0.5 moles of CO2. Half of 2 would be 1 mole of water. And then what's half of CH4? We would use half of it. That means we'd have half of this left over. And then I could kind of go back to grams and just say that I'm going to have half a mole of CH4, which would be 8 grams. There's only 2 there. O2 is all left over, so I'm going to have 0 of O2. I'm going to have half a mole of CO2, which would be 22, and I'm going to have 1 mole of water, which would be 18. So I think we're looking at choice B there. Okay, now this is if you can kind of just think about mole ratios and envision these moles reacting. But what if we just want to do it the long way? If you just want to do it the long way, you can. So let's just set this up and let's first predict our first product. Let's say we have 16 grams of methane and 32 grams of oxygen. Methane is 16 grams per 1 mole. The balanced equation suggests that for every 1 mole of methane, we produce 1 mole of CO2. And then we know that 1 mole of CO2 is about 44 grams of CO2. So you do the math for this one, and you end up with 44 grams of carbon dioxide could be produced. Again, could be. But we also have the 32 grams of oxygen. Oxygen is 32 grams per mole. The balanced equation ratios for every 2 moles of oxygen, we produce 1 mole of carbon dioxide. And then 1 mole of carbon dioxide is, again, 44 grams of carbon dioxide. Okay, this time when you set this up, you find out you could make 22 grams of CO2. Now, thinking back to limiting reactants, how much can be made? 22 grams can be made. Now, since that's coming from the oxygen is limiting, so at the end of this reaction, we have 0 grams of O2 left over. Okay, let's now use that 32 grams of oxygen. We know that's the limiting reactant already. Now let's predict how much water could be made. So we know that oxygen, 1 mole of oxygen, 32 grams of oxygen. The balanced equation again suggested that between water and oxygen, it's a 2-to-2 ratio. So for every 2 moles of O2, we produce 2 moles of water. And then we know that for every 1 mole of water, it's 18 grams of water. So 32 divided by 32 times 2 divided by 2. So we get 18 grams of H2O is also produced at the end of this reaction. Okay, now how much of that excess reactant, or CH4, will be left over? So let's just go from any one of the products we made. So we have 18 grams of water actually produced. And we're going to go all the way back. This was a 2-to-1 ratio. And we find out that 8 grams of CH4 were used. We started with 16 grams minus your 8. It means you're going to have 8 grams of CH4 left over. So I think this kind of shows how you could go about this problem the long way to calculate how much of these 4 substances are there at the end. Okay, what about question 13? This one's going to take a little less time because we're not having to go between grams and moles here. We're given everything in moles. So it says we have 4 moles of benzene and 15 moles of oxygen. Now again, conceptually, I'm looking at these ratios and saying this reaction requires a 2 to 15 ratio, but I have a 4 to 15 ratio. That means I have a little bit more of this benzene than I needed. So my oxygen is going to be all used up. Now I'm using this 15 moles, exactly what's in there, so that means I'm going to make 12 moles of CO2 and 6 moles of water. Now since I only needed 2 moles of benzene and I had 4, I guess I'm going to have 2 moles of that benzene left over. So I guess we have 2, 0, 12, and 6, which is that choice D there. Now again, mathematically, we could still calculate this if you wanted to, or if you want to confirm your work, just by putting the numbers in. So 4 moles of benzene, and the balance equation suggests that for every 2 moles of benzene, we can produce 12 moles of CO2. And then with our 15 moles of oxygen, the balance equation was a 15 mole ratio to 12 mole. 12 is less than 24. 12 moles of CO2 is what we actually can produce. Since O2 led to that, O2 was all used up and we have 0 moles of O2 left over. We could also say 15 moles of O2. Now that we know that it's the limiting, we produce 6 moles of water. And then if we wanted to find our excess, we could say that the 6 moles of water go back to that excess. For every 6 moles of H2O, you need 2 moles of benzene. So this means you're going to have 2 moles of benzene used. You started with 4, you used 2, you have 2 moles of benzene left over at the end. So you have 6 moles of water produced, 2 moles of benzene used, 0 moles of oxygen left over because it's all used up, and 12 moles of CO2 produced. Now for the last question here, for 14, suppose that 4 moles of, this should actually be CH4 or methane. So 4 moles of this are reacted with 10 moles of this. Which of the following statements is true? So now again, I want to really focus on my mole ratios. This should be a 1 to 2 ratio. 10 is a little bit more than twice 4. So that means this one is going to be all used up. I'm going to have 0 of that. Now this question didn't ask anything about the products, so I'm just going to try and figure out how much oxygen I needed to use for that 4 moles of CH4. So I'm going to say 4 moles of CH4. Now the balanced equation suggests that for every 1 mole of CH4, I need 2 moles of oxygen. This means that 8 moles of oxygen are used by that equation, or that reaction. Okay, now you started with 10 moles of oxygen, and you used 8 moles of oxygen, so that means you would have 2 moles of oxygen left over. So for this question, methane is the limiting reactant, and there's an excess of 2 moles of oxygen. Okay, I hope this helped maybe show you some of the long ways that you can approach these questions, but also just understanding and focusing on mole ratios and what those really mean can really get you through these and maybe save you a little bit of time. Okay, I hope that helps.